In 5.2, this talks about integrating growth and decay models. What we learned in the previous sections, we learned about the exponential growth and exponential decay. So recall, exponential growth was given by P of t equals P sub 0, the initial amount or the initial population, e to the kt, and the exponential decay, P of t equals P sub 0, e to the negative kt. So in this section, we're going to consider applications of integrals of these two functions. So if we integrate them, what happens? What do we get after integrating? Well, I'm not going to show the exact integration where it came from. I can if you want, but for exponential growth, so if we take that P of t and integrate it from time t equals 0 to capital T, that means I'm integrating the right hand side P0 e to the kt. And if you do so, that will be P0 over k times e to the kt minus 1. As a formula, for exponential decay, the integral 0 to t of P of t dt is the integral 0 to t P0 e to the negative kt, and that gives us P0 over k times 1 minus e negative kt. Those are the two functions that will help us find what it gives us as an integration. Now, why do we need this for? First thing, recall as well from before. If you invest P0, let's say, for t years at a rate k, and this is compounded continuously, then this is from previous sections, then P of t, the future value, is the original value times e to the kt. So notice P0 is the same as P of 0. And t is the time. This is called the future value. Future value of P0 after t years. As an example, find the future value of, let's say, $10,000 invested for 3 years at an interest rate of 2.35%. compounded continuously. So as soon as you see the word compounded continuously, means I can use the P of t equals P sub 0 e to the kt. We haven't start applying the integral yet. So P of 0, that's the amount you started with, which is 10,000. E is a fixed number, about 2.7. You put that on the calculator. K is the rate, which is 0.235. This is the same as 0.0. If you put that in the calculator, 2.35 divided by 100 times the time, 3 years. So then this gives about $10,730.44. That's the future value. Or they can ask you, find the present value for P of T equals 400,000 invested at a rate of 6% compounded continuously. For 8 years. So what was the present value? So note, what we learned is P of T is P sub 0 e to the kt. Notice, just if you like to see it, P of T, if you divide both sides by e to the kt, because we're looking for P0, what's P0? So if you divide this way, what you can do, you can get P sub 0 to equal to P of T. If you move this up, becomes negative kt, like that. So this is a formula to find the present value. P of T was 400,000, that's the future value. E negative, K was at 6%, so 0.06, and T for 8 years. And now we have to calculate this one. That gives us P sub 0 about $247,513.36. So it started at $247,513.36, and after 8 years it became 400,000. Now notice what I said compounded continuously. So what happened is, for example, let me go back to the previous example. So if we want to graphically present this, so this is T, that's P of T, time equals 0. So for this one, what happened? You started at 10,000. So the value here was 10,000 at time T equals 0. And then this grew up as time goes by, 1, 2, and 3. So as time went by like this, the value here, that's called the future value, became $10,730.44. That's the future value. What happened in the previous one, they give us the future value. So after 8 years, this was 400,000. And the question was, what's the present value, like this value? What was the value started with? So how do we use integrals here? Integrals, remember, is to add up the areas below the curve, the areas of the rectangles. And what we are going to do here is think about when we do, when we take, look on the credit card statement or something, when they charge you interest, they said daily. Daily means, you know, let's say you owe the bank $1. By the end of the day, they're gonna say, okay, now you owe us $1.02. By the end of the second day, you owe them not $1.04 anymore, maybe $1.05. It's like not 2 more cents, but more than 2 cents, maybe 3 cents. The next day, you owe them another 3 cents, and the next one is maybe another 5 cents. So they take what they got, not just they started with $2 or $1, and then they keep charging you interest on the $1, but they charge you interest on the $1 plus the interest they earned from you the first and second day. So that's called accumulated future value. So accumulated future value of a continuous income stream. So the accumulative future value of a continuous income stream is given by the formula A equals the integral 0 to t, capital T, r of small t, e to the k times t minus small t dt. And you can rewrite it, it's an easier way to do it this way, e to the kt, 0 to capital T, r of t, e negative kt dt. What are these things? So r of t, capital R of t, is the rate per year, and it's usually a constant given, and k is the interest rate for compound continuously. Capital T is the number of years for which this thing is invested. And that integral, if you integrate it, which you don't need to know how for now, you would get r of t over k times e to the kt minus 1. Provided that capital R of t is constant. If it's not constant, then we can't use this. So let's say someone, let's say Marlene, earns $125,000 per year. Is involved in, or let's say she got into an accident, let's say, and the insurance company decided is granting her a continuous income. So she got into an accident. The insurance company decided to give her a continuous income. Stream of, let's say, 50,000 per year for 30 years. She invests the money at 2.84% compounded continuously. In some kind of funds, mutual funds maybe. We need to find the accumulated future value of the continuous income stream. So how do we do this? Well, we have R of t. R of t is the money they granted her, 50,000. It's a continuous. K, the rate, 2.84%, which is 0.0284. Capital T for 30 years. So then we can use the formula A equals R of t over K times EKT minus 1. If we substitute them in, 50,000 over 30, E, K is 0.0284 times T, which is 30 here. Sorry, not 30 here. That's the 0.0284 minus 1. And A would give us $2 million. Okay, which is, if you want to round it to the nearest dollar value, that would be 2,366,780. The next thing, because we showed you how to find the present value, we also have what we call accumulated present value of a continuous income stream. So whenever you have a fixed income, let's say, maybe every year, every 2 years, every 3 years, that's called income stream. So for the accumulated value, present value of a continuous function is given by capital B r of t over k, similar to the one we did earlier, but here 1 minus e negative kt. This is the formula. Provided r of t is constant. If in case r of t is not constant, then to calculate the cumulative present value of a continuous income stream, we have to use the integral 0 to t, capital T, r of t, e negative kt dt. Example, find the present value of a continuous stream of income over 14 years. When the rate of income is constant at 39,000 per year and the interest rate is 5%. So again, r of t is the rate per constant rate per year. They're asking for the present value, so we give you the formula. If you want to do the integral 0 to t r of t times e negative kt dt, that's just the formula integral wise, but since r of t is constant, we can move ahead and find or calculate b using r of t over k times 1 minus e negative kt. Wait, the t doesn't go there, guys. T, it should be capital T up there. So fix that in the formula. Same thing here. This should be capital T here. So they give me out of t 39,000. That's why it's constant. And the rate was at 5%, 0.05. 1 minus e negative 0.05 times 14 years. This gives us 392,663. So the accumulated present value is given as $392,663. Now, how do we apply this as an application? Let's say at age 35, Lauren earns her MBA and accepts a position, a new position somewhere. Let's assume that she will retire at age 60, having received an annual salary of $110,000, and that the interest rate is 4%, compounded continuously. What is the accumulated Part A present value of the position? B, future value of the position. Again, we just gave you a formula for the accumulative present value given by B equals R of t over k times 1 minus e negative kt, capital T. So the fixed, the 110,000, that's R of t, and the rate is given 4%, so 0.04, 1 minus e negative 0.04. And then if you calculate the time she started the position, 35 years to 60 years, that's 25 years in total. And if we put this on the calculator, we get $1,738,330. Now for the future value, also we give you the formula. A equals R of t over k EKT minus 1. Again, same numbers, 110,000, 4%, E 0.04 times 25 years minus 1. 4,725,280.